Hello everyone, today we are going to discuss about resonance. So resonance is a special case of forced vibrations. That means it occurs only when the body is performing a forced vibration. So in that case, there will be a situation in which the body suddenly start vibrating with an increased amplitude, and then we'll say that the phenomena of resonance occurs. So let's discuss the resonance in detail. So as I told you that resonance is a special case of forced vibration. When a body performs forced vibration, we know that it is due to the externally applied periodic force. So the externally applied force will also have its own frequency, as well as the body which is vibrating with forced vibration will have its natural frequency. When both the frequency will match, so in that case the body start vibrating with an increased amplitude, and this phenomena we call it as resonance. Clear? So you can understand in a simple term, like suppose you want to play badminton, and just you are ready and going to play badminton, and suddenly your friend will come and say that okay, go and let's go and play badminton. So what will happen? So suddenly you feel more energetic, you feel more joyful because you just what you want to do, and suddenly your friend come and say that the same thing. That means the frequency of your thought matches with the frequency of your friend thought, and in that case the work will be done with a greater energy, is it? So that is what happened in this case. This is just a simple example I'm telling you so that you can understand the resonance. A body is performing forced vibration, and suddenly there will be a case where the body which is performing the forced vibration, its natural frequency matches with the frequency of the externally applied periodic force. So suddenly the body will start vibrating with an increased amplitude, and we say that the phenomena of resonance occurs in that body, and that vibration is known as resonant vibration. Clear? So this is what you have the resonance. I hope that is clear to you. Just you have to keep in mind 2 points, that resonance occurs only when the body performs forced vibration. Second, it will occur only when the frequency of the externally applied periodic force matches with the natural frequency of the vibrating body. If these two conditions are satisfied, then resonance will occur. So this is an important question. Condition for resonance. So as I told you, resonance occurs only when the applied force causes forced vibration in the body, and the frequency of the applied force is exactly equal to the natural frequency of the vibrating body. These 2 points are very important. Just keep in mind, then this whole topic will become clear to you. Now there are few experiments that are given in your book so that you can understand the resonance. So the first is given with the resonance with tuning forks. So this is the experiment where two tuning forks are taken. One is made to vibrate, kept on a sound box, and due to the vibration of the first tuning fork, the second will also start vibrating. And we say that the phenomena of resonance occurs in the tuning forks. So this is the experiment given, and what is the reason? So suppose you can see here the first figure, the second you can see that both are vibrating, resonance phenomena is going on. Now the first figure, why this going on? So this is tuning fork A, this is tuning fork B. Now the first one is made to vibrate by this rubber pad. It is stuck and it is made to vibrate, kept on a sound box with whose open end is just in front of the open end of the second sound box on which the tuning fork B is kept. Okay. Now when the tuning fork A will vibrate, it there will be forced vibration, so it forces the vibration in the air column present in its sound box. So because its surface area, which you can see, is very large, so its amplitude, the vibration of the means the air column will have the larger amplitude, and it will be transferred to this box because it is open end, so it will be transferred to the sound box of the tuning fork B. Okay, now they will also start vibrating with the same frequency as of the earlier sound box. Now these vibrations will be transferred to B, which is kept on this sound box. So B will also start vibrating. Now the vibrations of these sound box matches with the natural frequency of the B. So suddenly B takes up the vibration and will start vibrating. That means the phenomena of resonance occurs. Clear? And that is why both will start vibrating. Clear? So you can say that the two sound boxes helps in communicating the vibration and in increasing the amplitude of vibration. Due to the vibration of one of the tuning fork, the other will also start vibrating. This is the first example, first experiment to understand the phenomena of resonance. Now second is the example for simple pendulums. So four bobs of a pendulums. So they are suspended to a rigid support. You can say that a piece of stretched rubber string PQ through which four pendulums are suspended, A, B, C, D. The length of the pendulums are different. A and B, you can see that their lengths are same, while the length of C and D is different, means C is less and D is more. A and B will have the equal length. Also we know that in case of means simple pendulum, frequency is inversely proportional to length. F is equal to 1 by 2 pi under root G by L. So frequency is inversely proportional to L in case of pendulum. Now that means the pendulum which have more length will have the less frequency, and the pendulum having less length will have the large frequency. That means D will have more frequency, less frequency, C will have more frequency, and A and B will have the same frequency because of their length is same. Is it? Now the pendulum A is set to vibrate first by displacing its bob to one side normal to the length of the string PQ. So what will happen? So when A will vibrate, due to which all three will start vibrating, because all four are connected with the same string, so all will vibrate. And we'll see that when, as you can see that A and B will have the same length, is it? Because their frequency, the length is same, so their frequency will also be same. So as soon as A will start vibrating, so as the B, which is also vibrating, earlier it will start with less amplitude, but as soon as it matches with the frequency of A, so it will start vibrating with an increased amplitude. Why? Because the phenomena of resonance occurs in B. Now A and B will vibrate in phase with each other, that means in sync with each other. C and D will also vibrate, but they will vibrate with less amplitude. Which pendulum will vibrate with increased amplitude? Pendulum B will vibrate with an increased amplitude. Why? Because the frequency of the B now matches with the frequency of A. Clear? That means B will takes up the energy from A and now it is vibrating with an increased amplitude. And since A and B are in phase with each other, so A will take energy from B, B will take energy from A, and both will vibrate in phase with each other. Clear? So this is how the phenomena of the resonance occurs in this case. Now it is not important because such kind of questions will be asked in board examination. It's not like A, B, C, D all will be in the same sequence you will be given. You can see that in few of the questions which is asked in the board examination, the length will be different, like A and C will match, the length of A and C will be same, B and D will be same. So as you will get the question, you have to check which two pendulum have the equal length. First point. Then you will find out that which of the pendulum will vibrate with an increased amplitude very easily. So question related to it will be asked like this only, that which pendulum will vibrate with increased amplitude, or which will have the less frequency, which will have the more frequency. So this is the concept about pendulum. Now the second is also a case of a pendulum, but now here all there are four rubber balls taken attached with a string, they are connected with a board, and now you can see that it is the person is vibrating it. So you can see that which two length of the balls are same here, this one and this, these two are same, and blue is different, pink is different. Okay, now which two will vibrate in same phase? As you can see, these two ball which have the same length, so they matches, their frequency will match and they will start vibrating in phase with each other. So this is the example to understand how the forced and the resonant vibrations takes place in case of a pendulum. Now third is a case of resonance in air column. So again, this is an experimental setup through which we can understand how the resonance takes place in air column. So in it, there will be one cylindrical tube in which water is filled, and there is a cylindrical vessel which is connected with stand here, as you can see in the figure. So this is a vessel which is movable, through which we can change the length of the air column in the cylindrical tube. Clear? Now a vibrating tuning fork which is made to vibrate is brought near the open end of the cylindrical tube. Clear? Now in this case also, the length of the air column, the frequency is inversely proportional to the length of the air column in this case. Now we can increase, this is the air column where the air is present. So what we do, by changing the position of this, moving up and down, we change the level of the liquid in this cylindrical tube. Now when the level of the liquid is changed, it is found that a loud sound is heard while there is a change in the level of the liquid. So change in the level of the liquid means increase in the length of the air column. So at certain point a loud sound is heard. Okay, now again this process is continued. Again this is made, the level of the liquid is lowered down. Now it is found that suddenly after some time the loud sound is gone. Now it is not coming. Now again after some time it is again heard. So when it is heard, when the length of the air column becomes 3 times of the earlier one. Then it is heard when the length of the air column becomes 5 times of the earlier length. So it's like the length becomes 1 is to 3 is to 5, like that. At these positions the sound will be heard, and when the frequencies will be different, so that means at these positions the frequency of the vibration of the tuning fork matches with the frequency of the air column, then only the resonance will occur. So at these positions the frequency of the air column matches with the frequency of the vibrating tuning fork, and therefore we listen the loud sound. Clear? Now why I am saying 1 is to 3 is to 5 ratio? So this you will get, means you will study in the higher classes. There will be a derivation for it to find out how you will get this. Okay, so that's not what we have to go in detail. You have to understand this experiment only to understand the phenomena of resonance. So now what are the differences, because that is also important. Even resonant vibration, they are the special case in forced vibration, but what are the differences of the forced vibration and resonant vibration? So forced vibration, these are the vibration under an external periodic force of frequency different from the natural frequency of the body. Means the forced vibration takes place when the frequency of the vibrating body do not matches with the frequency of the externally periodic force. It is different, because when it will be same, then there will be resonant vibration. Clear? So forced vibration will say when the frequency will not match, natural frequency of the vibration do not matches with the frequency of the external periodic force. Resonant vibration, so resonant vibration, the vibration of a body under an external periodic force of frequency exactly equal to the natural frequency of the body. So that means during vibration, forced vibration, when the external frequency of the externally applied force matches with the natural frequency of the body, in that case the body will start vibrating with greater amplitude, and that vibration is resonant vibration. So in that case resonant vibration takes place. In case of forced vibration, the amplitude is small. In case of resonant vibration, the amplitude is very large. Now in case of forced vibration, the vibration of the body are not in phase with the external periodic force. In case of resonant vibration, it is in phase with the external periodic force. Last, these vibrations last for a very small time after the periodic force has ceased. That means when the external periodic force is removed, in that case the body will vibrate but for a very short time. But in case of resonant vibration, when the periodic force is removed, it is ceased, so it will vibrate for a long time. So these are the differences between the forced vibration and resonant vibrations. Now coming to the examples. So already we have seen the three cases, three experiments. So they are the examples of resonance. Now one more real life example, that is during passing a bridge, suspension bridge, when the troops passes, so they will be asked to break their steps. So why it is? Because the troops, they all have the habit of walking in sync, means all will put their right leg first, then left leg first, so like that they will march. They used to march in sync with each other, but when they used to pass a suspension bridge, so they are asked to break their steps. Why? So that the phenomena of resonance will not occur in the bridge, because if the phenomena of resonance will occur, so suddenly the suspension bridge will start vibrating with a quite higher amplitude, and in that case there are chances of the bridge to be collapsed. So that is why they are asked to break their steps. Clear? And how the resonance will occur? So when suppose they are all of them put their right leg first and their left leg afterward, then their right, so at that moment the frequency of the, means the natural frequency of the bridge, if matches with the frequency of the troops, so in that case that means the external periodic force which is exerted by the troops on the bridge, both will match, so suddenly it will start vibrating with increased amplitude. This is the condition for resonance, and if it is satisfied, so the bridge will start vibrating with increased amplitude. That means there are chances that it will get collapsed. So that is why they are asked to break their step. As you can see a resonating bridge here, and see how it is vibrating. Okay, so this is a very good example for you to understand the, there are advantage and there are disadvantage of resonance. Now in case of a radio and in TV receivers, so when we turn the knob of the radio to listen our favorite channel, we used to turn the radios, like if we like to listen 92.1 fm, 92 point what are they, 99.9 fm, or any other which is your favorite, so we used to turn the knob of the radio, is it? So what we do by changing the knob, so we are changing the natural frequency of the receiver. Now the natural frequency of the receiver when matches with the transmission frequency which is coming from the radio station, so when the two frequency matches, so there will be transfer of energy, and due to this transfer of energy, we used to listen our selected channel. So this is how the phenomena of resonance occurs in radio and TV receivers also. One more good example for you to understand the phenomena of resonance. So like this, there are many examples. If you will go through your book also, or means many examples are there of resonance. But the main thing that you have to keep in mind when the phenomena of resonance occurs is that when the body performs forced vibration and the natural frequency of the vibrating body matches with the frequency of the externally applied periodic force. If these two conditions are satisfied anywhere, then there will be resonance occurs. Okay, so this is the detail about resonance, and go through the topic, both lectures, free damped and forced vibration, and this lecture. And if you have any doubt, then you can ask me. Thank you.